Today, we're going to look at how to perform a paired t-test using SALT. So here's the situation. Several students are sitting in a classroom, and you have the students record their pulses. Another student runs into the class screaming to scare the students. You have the students take their pulse again. It's reasonable to assume that, maybe their pulses are going to go up, but we need to test this statistically. So the hypothesis we're going to test is, does scaring the students raise their pulse? We're going to test the 10% significance level. So let's take a look at our data, and this is a pretty classic paired t-test. Our data is going to fall into two categories, before and after, and we have 13 individuals in our study. We have their pulse in the first column from before they got scared, and the second column afterward. That is, you can pair their data, the before and the after. And it's used in lots of applications. But to perform this kind of hypothesis test, we first need to find the difference between their before pulse and their after. So you can type equals and click on their before pulse minus their after pulse and drag that down to find the difference. That is, what's their before minus their after. And a negative difference means that their pulse went up. And so we need to find the average of these differences. That's the average of them. We need to find the standard deviation of their differences. And we see that there's a sample size of 13 students. So their average differences was negative 8.92, and the standard deviation was 6.56. This is the average and the standard deviation of the differences, not of the pulses themselves. So we go to SALT, and we click on paired t-test. So we need to know the average of the sample differences. That was negative 8.92. The standard deviation of them, which was 6.56. A sample size of 13. And the question is, what is the hypothesized difference? So we want to know, does scaring them make their pulse go up? So our difference was before minus after. So if their pulse went up, the after pulse is bigger than the before pulse, and so it should be negative. So our alternative hypothesis is less than. We run it, and we get a p-value of 0.000182. That's really small. That's far less than the significance level, which indicates that we don't think it was just by chance that the students' pulses went up. We are convinced now that it is in fact true that scaring the students will cause their pulse to go up.